Hello, everyone. My name is Santiago Paternain, and I am an assistant professor at the Electrical, Computer, and Systems Engineering department. So, let me start with this problem, where what we have is an agent that is trying to navigate this complex environment. Okay? And the idea is that we want to move the agent from point A to point B while avoiding the obstacles that are in the way and also trying to avoid to fall into this stream river. So, another complication to this problem is that the terrain is very irregular, and therefore modeling the dynamics of how the system modeling the dynamics of the system becomes very complicated. Okay? So the way that we are tackling these problems is by standing at the intersection then between controls and machine learning. And one of the tools that we are using a lot is reinforcement learning. And I'm sure you have heard a lot of the reinforcement learning success stories where basically we have developed machines that are able to defeat humans at very complex games like the board game Go, but also at very complex video games. Okay? And how does reinforcement learning works? Well, it works basically in this form. So we have an agent, which in this case is our robot, that interacts with the environment. In this case, the map that we are navigating. So the agent has some state, which could be position and velocity, and it selects some action, which in this case is typically the acceleration. And once it selects that action, it receives or it transitions into a new state, and it receives as well a reward. The idea of this reward is to inform the agent of the quality of the decision that it just made. And the point here is that by doing this multiple times, okay, by collecting many rewards along the way, the agent is able to exploit them to learn a controller or to learn a policy that allows him to take the correct sequence of actions so to achieve the goal. So this framework has been, as I said, extremely successful, but mainly in simulated environments. And there are two main challenges that appear when we try to move from simulation to real physical systems, okay, which is what we are mainly interested when we think about control problems. And these issues are, first of all, safety. Okay, so in simulations, it doesn't matter if we fail catastrophically. Our agent might select a sequence of actions that destroys it, and it doesn't matter too much because we can always reset the system without any actual harm to the system or to people that might be interacting with the system as well. This is definitely not the case in real physical systems, okay? And therefore trying to guarantee the safety of the systems is one of the main challenges that we face. Okay? The other issue that these algorithms have is the problem of speed. Okay? So in general, we're training video games. We can always speed up the game, and we can play in multiple computers at the same time. And therefore, training an agent that would take, for instance, thousands of hours of gameplay can be done in real time, or basically in a couple of real hours. Okay, so in practice or in general, doing this for physical systems is not always possible. Okay? So trying to accelerate, trying to have our systems run faster, it's typically not possible. And also trying to run simulations in parallel, although it is possible, it becomes extremely expensive. Okay, so how to be able to provide faster algorithms for reinforcement learning? It's also another very active area of research. Okay? And what we are trying to do in our lab is precisely this. Okay, we are positioning ourselves in this intersection between control and machine learning, and what we are trying to do is to guarantee and to design algorithms that guarantee safety and to design algorithms that are faster. Okay, and we are also we are considering these algorithms in the context of a vast array of problems, where specifically we have been working on robotics, and now very recently we also started working a little bit on power systems. So, if anyone is interested in any of these topics, please do not hesitate in contacting me.